Swayam Prabha. Digital India. Educated India.
Welcome to the DTH sponsored course on micromachining. This is part 2 of sustainability issues in micromanufacturing. Acknowledgement the same, lecture by Professor Anshudhar Chayal, then chapter written by Professor Anshudhar Chayal of IIT Ropar, and chapter written by Professor M. Ravi Shankar et al. From IIT Tirupati, and he has also shared some of the slides for his lecture delivered on sustainability issues. Now this is my last lecture in this course, so I will once again like to share this slide with all of you. To fulfill your ambitious dreams, be honest, sincere, hardworking, and have junoon, that is passion, towards your objective. This will be very useful learning for your career. What has been done in part 1 of sustainability issues in micromanufacturing? If you recall, we discussed two major issues and definition of sustainable futuristic manufacturing. Because note it carefully, futuristic manufacturing has to be sustainable manufacturing if it is to survive for long period. And miniaturization and green manufacturing, we have discussed it. Why do we need miniaturization? What are the problems with the manufacturing processes in general and machining processes in particular for miniaturization of the products, and how much energy they are using during machining process as compared to traditional machining processes. Sustainability evaluation parameter, different parameters with the help of which index can be derived. Mechanical advanced machining processes and sustainability issues we discussed in general, and for advanced machining processes in particular, they were abrasive jet machining, ultrasonic machining. These are all macro machining and micro machining both, water jet machining and abrasive water jet machining, and their sustainable issues have been discussed. And we also discussed some conclusions regarding part 1. Now, organization of part 2, we are going to discuss in detail thermoelectric advanced machining processes and sustainability issues, which will include laser beam machining, electron beam machining, plasma arc machining, and electric discharge machining, and their potential health hazards and environmental issues. They will be discussed in this particular part. Electrochemical and chemical machining and micro machining processes and sustainability issues. The need and means to achieve sustainable futuristic manufacturing. We will discuss 3D printing, some applications of advanced micro nano machining, and conclusions. Thermoelectric advanced machining processes and sustainability issues. Plasma arc machining and sustainability issues. The arc energy is absorbed by workpiece material and it produces at high temperature as above the melting point of the workpiece material. Under these conditions, the work material quickly melts and may even get vaporized. I am not going to discuss working principle of any of these processes. I presume you have already gone through advanced machining processes or micromachining, where I have discussed their working principle with reference to micromachining. For machining organic materials by plasma arc machining, it necessitates large amount of inert gases which are harmful to the operator and the environment. Another harmful aspect of the plasma arc machining, metallurgical changes take place on the workpiece surface. When it is melting and vaporizing, definite metallurgical changes are taking place on the surface and subsurface of the workpiece material. In plasma arc machining, the volatile product formation takes place, evaporation takes place of the workpiece material. It affects the eyes of the operator, very important issue, and one has to be very careful. Hence, operator must use proper goggles or helmets. The dusty surrounding is another risk to the employee's health, and appropriate protective equipment should be worn by the operator wherever necessary. This becomes the responsibility of the operator not to work on these processes without appropriate protective equipments, just like goggles, helmet, etc., whatever is required over there. You can see here, this is the plasma gun, plasma arc is there, and you have this dust uplifted due to plasma jet velocity that is in this tube, and you can see here particle plasma interaction is taking place over here in particle inhalation, and once this inhalation of the operator takes place, you can see micro nanoparticles going inside the human body and creating lot of problems to the operator, and not only operator, also to the workers or the people working surrounding this particular equipment. So you can see here dust inhaled due to plasma jet velocity. Laser beam machining and sustainability issue. Laser beam machining and laser beam micromachining is one of the most popular micromachining process, and we should understand the hazards from this particular process. Laser beam machining, highly heat intense beam. It is used for rapidly heating and subsequently melting and or vaporizing the workpiece material for creating the necessary shape or geometry and dimensions by removal of necessary amount of material. So you can see it carefully, melting is taking place and vaporization is also taking place, and because of vaporization, fumes will be there in the surrounding, and operators and persons surrounding to this equipment standing over there have to be very careful. Single or repeated exposure to certain wavelengths of the laser damages the skin and other body parts. So one has to wear proper clothing, etc., to safeguard from this. Eye injury is a result of photochemical mechanism or thermal means that occurs when a laser beam interacts with the eyes, and this is very highly possible damage that one can have in the eyes because of little bit carelessness on the part of the operator or the person surrounding there. For minimizing the probability of laser beams exposure, set of the protocols and regulations designed for this purpose should be strictly followed. These protocols and regulations should be strictly followed, otherwise you are putting yourself into danger. If a beam enters into the eyes, the power of the beam is concentrated with the aid of the lens within the eyes about 0.1 million times more at the retina, eye retina. Hence, even a small amount of the laser beam leads to a big damage to the eyes. So, this is a warning to the operator and those who are using this laser beam for some other purposes also. Laser beam hazards to the operator, one can see in this picture. Laser radiation, eye concern, eye corneal and or retinal burns, contract, lens damage and skin burns, cancer, accelerated aging, etc. Then you have electrical hazard, high current, power supplies, because while laser production is there, you use very high current and large capacitors. Then secondary hazard, explosion, high gas pressure, arc lamps are used, fire, combustible material in vicinity of beam may take fire, chemical hazards, material emission, particulate and gaseous materials, vaporized targets, reaction products and laser radiation that we have seen. So, these are some of the laser beam hazards to the operator. So, one should safeguard himself or herself. Electron beam machining and sustainability issues. In electron beam machining, again very much useful for micro nano machining purposes, not so commonly used for macro and meso machining. A stream of the large number of electrons move as a small diameter beam towards the anode, that is the workpiece material. The workpiece attains very high temperature by the bombardment of, if it means the workpiece gets melted and or vaporized depending upon the properties of the workpiece material, thermal properties of the workpiece material. In the bombardment area, the high velocity electrons close to the light velocity. So, you can calculate whatsoever small is the mass of the electrons or negligible mass of the electrons, but it is moving with the velocity of light. So, half mv square you can calculate as the kinetic energy, which will be large enough. So, the high velocity electrons beam strikes the workpiece, the kinetic energy of the electrons gets converted into heat. This heat is responsible for melting and vaporization of the workpiece material. So, it is a very good process for micro nano machining feature creation. Electron beam machining is a cleaner process of the machining, but the interaction between the workpiece material and the beam of electrons generate X-rays which are hazardous and may lead to DNA damage. This is another high disadvantage of this particular process. DNA damage is of the primary concern for health and safety of the operator in case excessive leakage is there. Measures that should be taken into consideration for providing any hazards of health. First thing is install the setup within an enclosure properly. This is very, very important. All the setups related to this should be installed in a properly made enclosure. Then glass leaded viewing port should be there. You should not directly view on the beams, etc. Glass windows should be there for viewing those workpiece as well as beam. Doors interlocking should be there, and then following the methodology correctly, and only trained personnel should be allowed to operate. Please note it, only properly trained personnel or operator should be allowed to operate this particular equipment. Electron beam machining and health hazard continues further. Another potential hazard associated with electron beam machining, generation of dust due to vaporization of metallic workpiece material. This is another very important but worth noting hazard. Dust of metal gets deposited on walls that are inside the chamber. Operator is exposed to the dusty environment when the workpiece is positioned in that particular chamber before machining, and also when collecting or taking out the workpiece from the chamber after machining is over. And operator is getting exposed to that environment, so he or she should be careful that they don't get hurt from a health point of view. High voltage that is associated with the gun of electrons also presents the potential health issues due to electric shock. Ease of strategy of controlling the dust besides the personal protection equipment that would lower the exposure time to the dusty environment. So all these precautionary measures should be carefully taken, carefully imposed, and this becomes really the responsibility of the concerned higher authority in those industries. Electric discharge machining and sustainability issues. Electric discharge machining is one of the processes which is most commonly used on the shop floor of small scale industries, large scale industries, as well as medium scale industry. So the health hazard should be very clearly understood, and necessary precautionary measures should be imposed in all industries for the benefit, for the welfare of the employees. In EDM process, sparks are generated through discrete electrical discharges. They ionize the dielectric medium. Dielectric medium is used, which may be kerosene or other oil, mineral oils, or even water. So they ionize the dielectric medium and generate a plasma column between the electrodes, means anode and cathode. The sparks, that is plasma, result in extremely high temperature in the range of 8000 to 12,000 degree Kelvin. It locally melts and even vaporizes the workpiece material to remove the material. So operators' health concerns related to the release of toxic fumes when you are machining, depending upon the workpiece material, different toxic fumes are generated and they are evolved, and many times operators are exposed to them if proper exhaust system is not there. So related to the release of toxic fumes, vapor and aerosols during the process. Poor functional safety may result to fire hazard. In many cases, in many industries, fire has taken place due to this EDM process. So one has to be very careful. And also electromagnetic radiation is another hazard. Unwanted outcome, radiation, noise, eroded particles from workpiece and their emission. Dielectric fluids of synthetic and hydrocarbon based oil emit benzene fumes and vapors, polycyclic aromatic hydrocarbons. So these are all harmful to the operators and the people standing around it. Other harmful byproducts that include non-specific aliphatic hydrocarbons, mineral aerosols vapor due to degradation of oil and dissociation of their additives, and dielectrics are responsible for the risk of the fire explosion, hazardous emissions, sludge generation, toxic waste, high specific energy, uneven electrode wear, poor surface characteristics and slow machining rate. And you will be surprised to know that its machining efficiency is very low compared to electrochemical machining or other machining processes. Dielectric fire is the most common hazard, especially in confined an inadequately ventilated space when the temperature is near the ignition point. Various sustainability aspects in EDM, you can see it clearly, here the sustainability aspects of EDM, and you can see electromagnetic radiation, sharp edged particles, because you get the debris which are the molten material resolidified in the form of very small particles, and they may have sharp edges, and if you touch by hand by mistake, then you will get hurt and it may start bleeding also. Explosive composition and fire hazards, heavy metals in slurry, that is dielectric, gaseous byproducts. Now with this you should very carefully filter out and process before reusing the dielectric, because dielectric are always resupplied or reused, they are quite expensive. And gaseous byproduct and aerosol. So there are various sustainability aspects in EDM process. Volatile and toxic emissions can lead to operators' health concerns. Exposure to these emissions, finely suspended metallic particles, as we have seen in earlier slide, toxic aerosols, harmful gases for a prolonged period. If you are subjected to harmful gases and all these particles for a longer period, you may definitely have some or other kind of health problems. So be careful, use proper equipment to safeguard yourself. Flammable and combustible dielectric and dangerous magnetic radiation are additional sources of hazard, because earlier kerosene was quite commonly used for this particular purpose, not now. Other oils are also used for this purpose, and they should not be used here for the safety of the operator. Now manufacturers are making dielectric themselves and supplying with the EDM machine, so that some of these hazards are taken care of, they do not occur them. EDM using dry gaseous dielectric result in numerous environmental and health concerns, such as micro nano debris in breathing environment, sometimes interacting with the mucus, foul smell of dielectric, etc. EDM with oil based dielectric, carbon content on the machine surface is roughly 4 times higher, while with deionized water the carbon content is 50% less. So in most of the wire EDM processes, mostly it is the deionized water which is used as the dielectric, and in EDM also at some places manufacturers, no, not the manufacturer, rather users are using the deionized water as the dielectric. Considering environmental constraints, dry EDM appears as an alternative to traditional EDM. Some of the research work was done long back, 20 years back or so, at IIT Kanpur also, performing dry EDM and looking into the merits and demerits of the process, accuracy of the machine component and shape, etc. And that was published also in some journal, I don't remember exactly at present. Hydrocarbons dependent dielectric contribute significantly to the environmental hazards. Henceforth, the alternative dielectrics such as water dependent, gas based and dry EDM techniques also have been researched, and when we conducted such experiments of dry EDM long back, say 20-25 years back, we emphasized that why and how dry EDM is useful, and but there are certain problems also with dry EDM, but they can be overcome by researchers. Hydrocarbon dependent dielectric fluid causes skin irritation, explosion and fire risk in the working environment when the workplace is closed and not ventilated. This ventilation is one of the very big problem, and if it is not properly ventilated, you are inviting yourself unnecessarily the health hazard for the operator and the persons who are working surrounding to this machine. Indica neem oil, let us see, neem oil as dielectric minimizes the chances of emission of gas during machining, and it aids in the transformation of an oxide free hygienic breathing environment. So neem oil can be easily obtained, and I don't know exactly the price, but I hope it should be cheaper than other oils, and it has many merits to be used as a dielectric. However, it really needs further research for exploding its common use in EDM process. What measures should be implemented for the safeguard of the operators? For reducing radiation electromagnetically emitted by shielding machine, reducing possibilities of fire hazards using the dielectric fluids, level sensors, proper dielectric to be used, avoiding the use of dielectrics having flash points of 65 degrees centigrade or below, applying suitable disposal of the waste, this is another very important point, and raising awareness of the operator for not using high voltage resulting in severe injuries or sometimes even the death of the operator. So really speaking, I very strongly recommend you follow all these measures for the safety of the operator and surrounding people, and also not only operators or human beings, also the equipment that are placed near to such machines. Conclusions: focus on improved technology R&D and on sustainable manufacturing is essential to enable sustaining our quality of life and safeguarding the environment. In the case of micromanufacturing, there is a serious lack of attention to this issue on the part of industrialists, government and policy makers in general and researchers in particular. I very strongly agree with this issue because at least I have not seen so much emphasis being given by the industrialist investing some additional money. Also the government and policy makers are really least bother about these issues, which is really not good. Several strategies are possible, however, due to complex nature of the market, very few broadly applicable solutions are evident. That is what I have just told. Other than facility upgradation, process scale up and process optimization, this is being done by the researcher, but least is being done by these people, industrialist, government and policy maker. Now let us take electrochemical and chemical machining processes and sustainability issues. It works on the principle of material removal by localized anodic dissolution, anodic electrochemical dissolution process using electrolyte. Common electrolyte used in ECM include diluted salt solution of NaCl, NaNO3, etc. Acidic electrolytes, say HNO3 is more common for micro electrochemical machining or electrochemical micromachining. Citric acid, environment friendly alternative is there. Then it produces many byproducts such as sludge having traces of heavy metals, metal ions, oils, nitrate and harmful acids. Electrolyte is contaminated by heavy metals and chemically altered byproducts such as hazardous ammonia, chromate and nitrate, because we have already discussed that during electrochemical reaction many types of byproducts are produced. They are known as sludge, and some of them are really harmful. Efficient local exhaust system should be used so that hydrogen gas is below its lower limit of flammability and aerosol out of operator respiratory tract. So proper exhaust system in all kind of the manufacturing processes is always required. Inhalation, ingestion, skin and eye contact are all possible health concerns if exposed to trivalent chromium compounds, and if it is being machined, then you are going to have these compounds formed over there. Nitrites and nitrates cause numerous health consequences such as vitamin A shortage, reduced thyroid gland function and blood hemoglobin reactions. Toxic vapors which are generated during the electrochemical dissolution of workpiece material, toxic vapor, electrolyte contamination and splashing are various occupational health hazards. Local exhaust system for ventilation, enclosure of the process setup and personal protecting equipment, all the three are very important. Ventilation, enclosure of the setup and personal protecting equipment are the efficient method in limiting workers' exposure to nitrogen and trivalent chromium. We continue with this. ECM also uses acidic electrolytes like HClO4, HCl, H2SO4 and HF. It depends upon which material you are going to machine. Accordingly, you have to choose right kind of the electrolyte, and that is the acidic electrolyte in this particular case. They are poisonous and hazardous for the machine operator. They also harm components of the machine tool and eventually destroy the machine tool, surrounding machine tools. Electrolyte splashing may result in skin irritation, eye contamination, dermatitis, etc. Inhalation of smoke or gases which are exposed during the electrochemical dissolution of the workpiece material. So, inhalation of smoke or gases produced by the use of chloride and nitrate based electrolytes for the long period can cause ingestion, kidney, liver, skin and eye related diseases. So, normal mineral water as electrolyte in ECM process is a superior substitution of conventional acidic or basic electrolyte. This is a very important advice one should try to follow. I will even go up to the extent that even at the cost of machining, if you can use mineral water oil or deionized water, whichever is convenient, then that will be preferred, or that should be preferred, keeping in view the health hazard for the operator and the safety of the surrounding machines. It is completely eco-friendly and non-corrosive in nature, resulting in the greener ECM with higher efficiency besides precision at the considerably low cost, because mineral water or deionized water, comparatively they are cheaper and you can recirculate them. For sustainable ECM, environmentally friendly sodium carbonate is recommended as electrolyte. Local exhaust is provided for preventing hydrogen gas concentration to the limit of flammability, besides removing the mist, that is volatile organic compounds inhalation, from the breathing zones of the worker. So we can come to the next one, that is chemical machining and sustainability issues. Chemical machining uses acid agent. It adversely affects environmental surrounding. It has shortcomings in storage, handling, besides damaging various materials. Chemical machining hazards depend upon the substance properties at the time of contact and concentration with the alkali and the acids, because machining takes place because of the chemical reaction over there. Effects on health of labor: irritation, injuries due to corrosion, besides burns, severe damaging of the eyes, even leading risks in the lung cancer, larynx. These are quicker and very often irreversible problems. Aerosols such as sulfuric acid and nitrogen or liquid substances, they are corrosive in nature and polluting means in the air. They form corrosive gases combined with the water for forming the acids which precipitate by the rain. And fumes of the acid, besides acetic gases, damage the flora. Photochemical machining, again a very commonly used machining process in case of micro and nano machining, is carried out with the aid of the solution in the aqueous state of ferric chloride at the temperature over 50 degrees centigrade. Ferric chloride is relatively cheaper, acidic and readily available, besides versatile. Now, next section is need and means to achieve sustainable or futuristic manufacturing. Manufacturing in general and machining and micro machining in particular is being discussed in these two lectures I have already mentioned. Why there is increased focus on sustainability? Dwindling non-renewable resources. You can see here non-renewable resources are dwindling, and these are some of the materials that are dwindling, like copper is there, platinum, all the list is there. So they are dwindling. So there is always a need for sustainability, and sustainability not only environmental or a health problem, but there are going to be the scarcity of these natural materials as listed over here. So environmental performance index, this is very important advice, that we should try to develop environmental performance index and evaluate each process on this index, just like we evaluate the tool material with the help of tool life. According to Yale University 2014 API, India ranks 155 out of 178 countries. This simply means we are very poor in this particular case. In the last 10 years, API has improved to 5.4%. Environmental problems: air pollution. China and India often get a lot of attention for their bad air quality, and rightly so. Cities in these countries have levels of harmful particulate matter way beyond healthy levels. We keep hearing and seeing on the TV regarding certain big cities like Delhi, where most of the time health issues are there and air quality is very poor. Air quality is emerging. Air quality in emerging nations is particularly bad, with industry the main cause. This is one of the main causes, but there are other issues also, not only the industry. In India alone, premature deaths from outdoor air pollution increased from 100,000 to 600,000 between 2000 and 2010. So this is very alarming situation. Now you can see here, I have shown the picture over here, world map, and this is saying approaching physical water scarcity, and India is here, you can see in yellow color. That means in near future we are going to have scarcity, serious scarcity of water. And this is what our ex-late Prime Minister Dr. APJ Abdul Kalam also warned the Indian nationals many times that don't waste the water, and this is what is going to happen there. So environmental problems are there. India economic water scarcity approaching physical water scarcity and so on. So many problems are there. One has to be very careful. Like share of global cumulative energy related carbon dioxide emission between 1890 and 2070. Now it has changed a lot, but we can see US was highest one, 28%, Europe 23%, and other countries just 5%, Russia, China 9%, Russia 11%, and so on. So by 2050, roughly 80% of the world's population is expected to live in cities, and all kind of problems are going to be there in cities, as we have just seen. This map we have just seen over there. Solution: need for improved technology and R&D. Two major approaches for sustainability problems. Reduction in consumption, that is very, very important. However, developing countries not interested, because I can tell you North America or America and European countries, they don't believe much in this, and they use and throw once use and then throw culture is there, which now they are also changing. They are going back to what India used to do it, and what India is doing, that recycle the same product by modifying it or by reusing it again and again. Modern economies are consumption driven, and very few consumers willing to accept trade-off for a more eco-friendly product. This is another very important issue, that consumers are really rarely seeing what are the eco-friendly products that she should purchase. And improve technology, which is the responsibility of engineers and researchers, they hold the key. Need for sustainable manufacturing, these are the four pillars: technology and human resources, economy, environment, and society. All the three are very important along with technology. So technology should be based for economy, environmental friendliness, and society friendliness also. So you have sustainable development, innovation, creativity, education and training, and they should center around these things. And this is from the source Professor Jawahar of University of Kentucky. Some slides are from there. Sustainable manufacturing, elements and scope, products, processes, systems, and all of them are connected. And all the three should be concentrating, should be taking care of sustainability of the manufacturing processes. Sustainable manufacturing. Then only people can survive. Doesn't matter whether system or product or processes, all the three have to be sustainable, or they should be believing and performing green manufacturing. Need for sustainable micro and nano manufacturing. As you can see here, publications not very good, not very important, but people are concentrating now, and you can see total nano publications, red color, and EHS nano, this color, and then green is nano life cycle assessment and so on. So it simply indicates that research publications are also substantially increasing related to sustainability issues. Next, why do you need for focus on sustainable manufacturing? There are certain reasons. Most of them we have already looked into. Manufacturing lies at heart of industrialized economies, but maximum wastage per year takes place. Largest emission contributor for many products are manufacturing industry. You can see over here this billion of tons. This is the material wasted per year. It is billion of tons, and you can see maximum is from manufacturing over here. This is due to manufacturing. This is mining. This is oil and gas, agriculture, municipal discards, coal, other. So you can see maximum discharge, maximum wastage is from manufacturing only, especially that of material. And you can see here estimated energy usage at various stages of life cycle of a 32 MB drum, etc. Now these are, you can see over here, this is IC fabrication. Maximum quite a bit, this is the total. So don't consider, this is the total of this, and out of this, this is due to the IC fabrication, because IC fabrication is micro nano fabrication, and I have already told you that micro nano fabrication or micro nano manufacturing takes very large energy per unit production, because they are, most of them are multi-stage production. That's why many researchers, including IIT Kanpur, they have developed some of the processes which is 1 or 2 steps manufacturing processes rather than multi-step manufacturing processes like Liga. So various researchers are working very hard to overcome some of these problems. Sustainable micro manufacturing strategies, reuse, very important, reuse and remanufacture. That is what we do in India, reuse the same product again and again, not just like Western culture that use and throw. And also remanufacturing, now they are also adopting these two words, reuse and remanufacturing. In the Western world, they are now scientifically and systematically, they are working hard on these two issues and they are implementing it there. You can see here value in dollar, the product life cycle stages. You can see this is pre-manufacturing is this much, this is for manufacturing cost, this is use, disposal and landfill. Now if you see further, in place of landfill, then we can reuse this after use, this can be reused, so the value is not changing too much, it is not going to the landfill or disposal, and then disposal after reuse, and then recycle it, and again its value increases. Here is the value, you can see it, and this is the life cycle, and then it is the saving in dollars gained by manufacturer because they are recycling it and recover it and then redesign the product, remanufacture, and savings gained by consumer. So you can see this is what you can see in India and other countries also now, that automobiles, they are not advising you to throw it just like that, rather they are advising you to give it to the manufacturer on certain minimal possible cost. Manufacturer will reuse the parts which can be reused carefully and safely, and then only whatever cannot be reused at all, only those parts and of the automobile and other equipments are thrown, rest of them are reused. So people are now working hard to implement this kind of the diagram where reuse, recycle, recover, redesign, remanufacture is being used, and this is again after remanufacture, this is again used. So post use, normally people are throwing at this particular point, see it carefully, but now they are coming up to this point and then they are reusing it. So this is all very important change that is taking place in the world culture. Second and subsequent life cycle starts over there when we say over here. Energy requirement for different manufacturing processes. Just let us have a look, very important diagram over here. You can see, now very important thing that I want to emphasize here is a comparison of specific energy required for various micro manufacturing processes. It also includes nano manufacturing processes relative to conventional manufacturing processes. Now you can see here most of these processes lying over here, they are the conventional manufacturing processes, and those processes lying over here, they are the micro nano manufacturing or advanced manufacturing processes, and you can see many times more energy requirement is there in these processes compared to this. Order of reducing energy required. Now you can see here oxidation is taking maximum energy, drilling EDM, second maximum, sputtering, carbon nanotubes, CVD, dry etching, wire EDM, grinding, and so on. So one should try to remain in this area, but that is not possible. If you are going for micro nano manufacturing, you have to go into these processes. But researchers and scientists should try their best to modify these processes so that their energy requirement is reduced. Now, need for focus on sustainable manufacturing. This is CO2 emission. You can see here, this is Europe. Now this is the year here, and this is the billion, metric tons billion. Europe was at one point of time giving maximum CO2 emission, and then this is the North America, this is the Asia, and then this is the Middle East and North Africa. But with time, Asia has crossed. By 2000, Asia is giving the maximum CO2 emission, exceeding that of North America and Europe. Now these are some of the industrial ecosystem at Denmark which people are trying to work on, so that minimum CO2 emission and unfriendly gases are left over there in the environment. And this is eco-industrial parks which are being developed. You can say gases evolved from here, they are used somewhere else, and so on, and surroundings are made with the trees, etc., so that environment doesn't get worse. So this is schematic view of evolving industrial symbiosis at Denmark. Conclusions. To cope up in the race with the advanced countries, for that matter any country has to spend enough money on the innovative R&D activities. I have already shown you in one of the lectures that India is just spending around $60 billion on R&D, while China is spending around $556 billion, which is more than even North America. So to be the leader in manufacturing, you have to spend a lot of money on R&D. No matter how much you spend on R&D, dedicated team of young, intelligent, honest, and hard-working and sincere researchers is always needed. Micromanufacturing and additive manufacturing will have an important place in the manufacturing industry in future, maybe after 15 years, 10 years or 20 years. Additive manufacturing is going to be the leader of many manufacturing industries. Focus on improved technology, R&D, and on sustainable manufacturing is essential to enable sustaining our quality of life. And in the case of micromanufacturing, there is a lack of attention to this particular issue on the part of R&D and industries. So with this, I complete my last lecture on micromachining, and I thank you all for listening me. And please note very carefully last two lectures regarding sustainability if you want the survival of these micro nano manufacturing processes. Thank you very much once again.